Today we're going to look at one of my sets. It's not that we've run out of customer repairs. I did promise another dealer that we'd look at a great GT858 in great detail as far as the phase lock loop goes, because he's got one in with no transmit. Now this is a set that I did some service work on about 15 years ago before we started this channel, and at the time I was using the sweep generator method as shown in the service manual to do the receiver, and at that time we didn't have a sweep generator. Now subsequently I've shown that technique on bench 2 behind me several times, but then we moved over to using the synad meter method, which really came out after the service manual was printed, so that's why it uses the sweep generator method, which is rather cumbersome and time consuming. So this one isn't set up on receive right. But what we're going to do is unset up the transmit so we can go through all the things you've got to do for a non-functional transmitter. So the first thing I need is a great wired microphone. So there's a microphone which says great on it, so this might be a bit dusty. I haven't done a great set for a bit, and you know I love them. Everybody hates them, so I'm bound to love them. I'd be the one who bought the wonky dog with one leg, wouldn't I? Right, power supply on. Test equipment. That's a dusty socket, we better clean that before an on-the-air test. So all the lids are off. Undo the speaker. So this is a Lake 850 Manxman. Roger D's at Nottingham at Daybrook with the distributors. And what we need to do is unsolder the tin plate screen which covers the phase lock loop section. This is to stop microphony. You'll find that it isn't a factory thing done, but you can end up with this physically rattling and causing the radio to transmit and receive rattles. Back in the day, it's something valve stuff suffered from, and a lot of people thought that when transistors and subsequently microchips were the thing and valves were not a thing, then we would be rid of microphony, but it isn't the case. So there we have the general purpose synthesizer chip, which this set uses, rather than something which is pre-programmed for UK channels. Don't really need to know the date, but it's the 5th, I think, today, 5th of February 24, Lake 850, and it's one of our sets, so it's TSG stock. Probably the only 850 we've got, but at least it doesn't have any silliness like people unwiring the low power switch and that. Right, so I'm going to put picture in picture. I might take it back off again, just to see if it still works after 15 years. Actually, in my living room. People will have been sick of seeing the sight of it. Right, we're lit up, it's on channel 20. It's doing 250 milliwatts, perhaps it's on low power. It was kind of in between the two. So as we stand, it's 2.1 watts, so it's going to need some service work. it is going to need some service work. So our dealer customer friend says his is receiving, but it isn't transmitting. Now here's the next thing. These don't have an extension speaker socket. Oh, that is so frustrating. Who thinks it's frustrating? Yeah, you all do. I mean, the 30,000, you can end up buying one with an extension speaker socket and one without an extension speaker socket. So even that's 50-50. I didn't know there were any Fidelity Thousands without extension speaker sockets, but they have appeared. Part of me actually wants to fit one to this set, but then it wouldn't be original, would it? Right, so we need to kind of clip a crocodile clip, use Mr. Chippie's yellow one, to our test instrument speaker, just so we can hear the receiver receiving badly. I think blue's hot. We'll put the signal generator on and assume the radio is going to work on the correct frequency of 2779.125. So which one's hot and which one's cold? 206 milliamps. It's hard to tell at this point. I'll just tell you what, we'll just connect it with two leads. Bit of a dirty volume control, so that's candidate for the service hole, which happens to be behind me. Hopefully we can waggle that around and it will get better. Otherwise we'll end up changing it. It didn't do that in 2010 when we last didn't finish it. So, service manual. So, your VCO. Set the channel to channel 20. Right, we've done that. Set the CB to transmitting condition, connect an oscilloscope to pin 8 of IC201. And then adjust L201 so that that pin 8 gives a logic high. I've probably also done this with a logic probe before now. So we'll put the oscilloscope on. We'll use this one just so it can be seen by the overhead camera. If I hook that round there, that should be a handy earth point. Pin 8, we ought to have proby things, but we haven't. Let's put the other glasses on, just in case I can then see something. And it says, adjust L201, that pin 8 is logic high in transmit. So L201, 206. Can I see the others? No, of course I can't see the others. Okay, so that's 204, not 206. 206, 204, 202, 201. So 201 is that one. And pin 8, pin 1 is at this end. So it's this row next to the crystal, not against the shield case. 1, 2, 3, 4, 5, 6, 7, 8. So it's an 18 pin chip So you can count from this end 9, 8, second one in. It's quite possible that that's a test point. Let's go back to this diagram. Yes, it is. That pin goes to pin 8. You can see there is a pin. How handy! So you may hate these sets. They're very, very reliable, especially in the phase lock loop department. I'll press auto set on the oscilloscope so that it finds it properly. And let's take L201 out of lock. So L201 is now out of lock, we've got no transmit. So if we advance that, getting something. And you can see that's our logic 1. Let's put our walkie-talkie on, and I'm going to do that again because there's another way of hearing when it's in lock if you've got enough of it working. And here we've got hello 1 2. So I'm going to take it out of lock. I'll just turn the volume down because I know it annoys some people. Let's take this right to the bottom. So in transmit, I'll tell you what, I'll put this picture in picture still on, it is. Let's put it on that meter. So I'm pressing transmit. So we've heard it and we can see it. So I'm kind of taking it to the centre of that lock point. We can hear it on the walkie-talkie, we can see it on the oscilloscope, and we can see the power on the meter. So that's our first thing. Next, set to receive condition and adjust CT202 so that pin 8 is logic high. Now, our friend already has receive, but we're going to adjust it with CT202, which is the white one. I'll prove it's the white one. It's 202. The one we do for frequency is 201. So, here's the second stage, which is receive. So, 202, so we've got logic 1. So we're out of lock. And we're in lock. Now I wonder if we can get these same readings using an electronic voltmeter. Take this off, because I'm always looking at even easier ways to do things and cheaper way to do things. So let's see what happens as an experiment. I'm not an experimenter, but today I am. I could do with another crocodile clip. So we've got voltage of 6.5, which is logic high, to take it out of lock, we get 6.1. 6.5 in lock, take it out of lock the other way, 6.1. So it's not a big difference, is it, between lock and unlock? See what happens in transmit. So we're going to take the, I'll take this coil all the way back to the bottom so it doesn't transmit anymore. I'll press transmit. Then we'll bring this up. .22 millivolts out of lock. .9 volts in lock, take it out the other way, and so on. So that's another way. For that first stage you could use the digital voltmeter or another type of electronic voltmeter to get that logic high, and on receive it doesn't make a lot of difference. It's between 6.1 and 6.5. So we have done it as the thing both with the oscilloscope and with the electronic voltmeter. So our next thing, when we've done that bit, select channel 20 and a frequency counter to capacitor 55, and you're looking for maximum. We're not going to put a frequency counter on capacitor 55, but if you hadn't got any transmit, you could do. So where is capacitor 55? I might even do it just for a laugh. Capacitor 55. 58, 57, 55 is that one. So that coil, that capacitor, let's put a, we'll do it. Take that away. Bring the oscilloscope back. Because we do the frequency bit of it at the end rather than at this stage, but there may be people where there isn't enough of it working to be able to see it doing this. So if I connect, I don't know which side of the capacitor we're going to, but let's have a look back at the manual. Capacitor 55. So let's connect to that leg. So we can see off the oscilloscope we have 277917 in transmit. 277917. Let's go back to what the manual says. Select channel 20, frequency counter and VTVM to capacitor 55. Adjust 207, L4, L5, L6 for maximum reading, and the frequency of 2779 and adjust CT 201, which is the frequency set one, for the correct frequency. Well, I do it on the frequency counter at the end using the test set, but this is the way the manufacturer expects you to do it. So adjust 207, L4, L5, L6. Now we're on this one. 207, L4, L5, L6. Let's make sure we're doing the right ones. 207 is that one. L4 under there, 5 and 6. 207, 4, 5, 6. So let's see if we can get maximum amplitude doing it this method. And there we have it. And you can set the frequency. They say 277918. Let's turn it to 125. It'll be 13. I haven't got enough digits on this meter. Well, that's as low as it's going to go on there, but this isn't calibrated, whereas the other is. So we'll take that probe off. I'll turn the radio off. Turn this back off again. Put it on one side. But the idea here is that we've got ourselves that logic 1, so we know its VCO is set. They've had you go through these 4 207, L4, L5, L6 with the test point on capacitor 55, which also goes to the base of transistor 17. And so you know there's something coming out of this section. So if you've got logic high there and you've got nothing coming out of this section, you can go back on these individual coils, and we can see through here where they're connected. You could have an open circuit coil. For example, L6 is easily damaged. If somebody puts a side screw in longer than safe, it ends up pushing over and breaking L6. And there was a lot of that back in the day. So a lot of the times you've got no transmit is because L6 has been pushed over. It may not even show as being pushed over, but it could have broken away from the print. So that's another good reason. So we've done the test point on pin 8 with L201. We've connected the vacuum tube voltmeter, as they call it, or the oscilloscope, to capacitor 55, or the base there. We've gone through those for peak, and we've set the frequency. I don't like the frequency being set at that point with CT201, but that's the way they want to do it. I'm now going to hope that we've got enough signal. Yes, we have. And we're on low power, so we should be able to do the rest of the tune-up. So if you remember, we started at, it was about 2 watts, wasn't it? It was a little bit more than that now. And we're at 2779,089. I'm going to bring it up on frequency with the frequency counter on the test set. I'll leave it there for now. I didn't show you that because I'm still concentrating on the power. So we're going to go through these. Remember, these sets are 2.5 watts, and sometimes you'll get 3.5 watts, and I've once seen 4. So there we go at 2.3. Bit like modern sets, aren't they, with lower power than you'd like, but you know, these weren't pretending. I think that's been touched. I don't like to have that touched because it's done with the spectrum analyzer when it's fitted. So at the moment we've got 2.5 watts. I'm just going to go back on these because now we've got it transmitting properly. I can just touch these up on using the test set. So that's absolutely at the correct point. And that was at absolutely at the correct point. And so was that. So we gained a little bit there. So the first 3, definitely by that first method where you're monitoring the capacitor 55 there, those first 3 are going to get peaked properly using that method. But this last one needs looking back on again once you've got the rest of it working. So we whisker away from 3 watts there. I don't know whether this has suffered from coil silliness. I'll just check. Yes, it has. The phantom coil stretcher has not helped it at all. Let's go to the other range. So this one should be done with the spectrum analyzer. I'm just making sure it's not making any difference, which it isn't. So I'm now, the set's warm, of course. It's been transmitting now for a few minutes, and it's doing 3.5 watts on channel 20. So we'll write that down. It even smells warm. Anyone seen a pen on here? There is, of course, a planet where all pens go to. 3.5, well, it wasn't there, was it? 3.5 watts. So, go to channel 40. And it's 3.3 watts. Go to channel 1. And it's 3.55 watts. And back to channel 20. Our current consumption is 730 milliamps, and low power on this radio it's 350 milliwatts, which is of course 10 dB attenuation, just as it is supposed to be. So there we go. I haven't put the test set on behind me. I will do, and then in half an hour we can do the deviation. But just for the sake of the test initially, 1212, are we set up for this? Wallow. It's saying it's about 3.8, so it may be lying, it may not. So we've done that. So it's 6.1 is out of lock. 6.5 is in lock. Pin 8 and frequency, I'll put that up on the screen. So I don't like their method doing it at the capacitor 55, and I'm using our test set 2779121. That will change as the test set warms up. So I'm not so bothered about the what the meter says at this stage. Now, what I want to do is this receiver. That's interesting. There's a dry joint at the volume control. So back to our crib sheet. So I wanted to set this up properly. I've shown this time and time again. This was a transmit tutorial, and that has ended. As far as the receiver goes, it's transformer 4 and 5 for maximum S curvature. So 4 and 5 4 and 5 are these two here. The rest, you've got the IFs and you've got the front end. So let's see if we can get this curvature correct first. Let's go over to the oscilloscope. Now we've got 2 points here. I'm going to go for the second point. It's frustrating when that happens. And at the moment, let's put the cyanide meter on. We've got what? It doesn't sound nice. And we've got just under 3 microvolts for 12 decibel cyanide, which is I think the word is crap. Just see if we can get these IFs better. That was spot on. That was spot on. That was spot on. Of course, there may be a fault on the set. Let's look at the front end. No, they're all spot on. So, is it trouble with this one? Not good. It's still 2.7 microvolts. Or are we on the wrong? Let's just see what happens if we take the detector off. First peak, second peak. The first peak is going to give us better sensitivity, so that must be the right peak. Let's go through these again. I don't think we're going to be right. No, we're still at 3 microvolts. There must be something wrong. So I think if we change the filter there, either filter could be faulty to give us a duff receive. Because at the moment it's 3 microvolts, so it's far too deaf. So I'm going to take a break, and I'll come back and I'll have changed that filter.